Oh, sorry, wait a second. Last time what we have seen from a given NFA, learn how to construct a two right linear form. That was so today class, right? What we're going to say is the reverse of last topic. So in today's class, right, we'll be provided with right linear grammar, and then when I say right linear grammar means by default you might be knowing like this is regular grammar. This is regular grammar, and then from this, right, we are going to construct an NFA. This is going to be the given part. Let me just write given this one, and then our target will be NFA. NFA. Now, so this one, right? Let me consider grammar G, and then let me write RL. As per the grammar definition, this is N, comma T, comma P, comma S, where N is the set of non-terminal, T is the set of terminal, P is the production, and then S is the start symbol. And then regarding our target and FA, I mean the machine which we are going to construct from the given regular grammar, right? Let me represent that machine by M and FA. Okay. And then for a machine definition, right, we know that Q, comma, summation, comma, transition function, then initial state, this. I don't have to explain each term once again, right? Now, from this given right linear regular grammar, we're going to construct NFA. Now, certain rules are there. This is given. From this, we have to construct this. So, from the information provided to us, right, we should fill this Q, this transition function, this. Okay, that is our target. Now, Q will be equivalent to N. Okay, I suppose I have written. See, hereafter I'm not going to allow anyone to enter. It's quite disturbing me. Somebody is trying to enter. Okay, now, and non-terminal will be set of Q, and then one more extra final state, because this grammar will not provide the information about final state. So Q, this capital Q, right, will be a set of states, and then we have to introduce another one new final state. So let me call that one as F1, including new final state, which will be represented by, let me represent that one by QF. Okay. And then the terminal T will be equivalent to this one. And then start symbol will be equivalent to initial state, this one. And then now the production from the grammar, right, will be having the production, but we need transition function from that one. So transition functions, right, will be converted from production. So let me just write the production. And then from this production, right, we have to convert let me just write the rules which we are going to utilize. After this, right, I'll be taking the example so that way you can understand it very easily. So production rule number 1, for a non-terminal, there exists a production, there is a production of and replaceable by epsilon, then treat or consider that non-terminal, in my case capital N, as the final state. Okay, you might be confusing right now at this moment, but after the example, right, it's clear. And then number 2, if there exists a production of this format, this N, M, and all, they're all non-terminal, then at, I'm not going to allow, then at delta N comma A, this one. Number 3, if the production is of this format, then at delta N comma A, F. Okay. And then if it is confusing, right, instead of QF, you can introduce some non-terminal. It's up to you. There's nothing wrong in that one. So I've introduced QF. Or maybe I'll just do it like this. Maybe instead of QF, right, let me just say F1. Don't get confused, okay? Or else I'll just write F. And then in this one also, let me just write F. Yes. Now let me take one example. Let me consider one example. In that example, I'm going to apply whatever I have just discussed right now. Now, let me take one example. S, no need. We all know S is a start symbol, so no need to specify that one. And then production, right, let me just number it. Okay. Now this is the given regular grammar to us, and then this regular grammar is of right linear format because the right hand side terminal followed by non-terminal. All the non-terminals lies on the right hand side of the terminal, hence this is right linear grammar. Now our target is to construct the machine NFA. So I would write a few sentences like describing that. Let me consider this M as the machine. Like, let me just take it. Let me just write directly. Q comma this Q not. This needs to be filled. Now, as per the rules, Q will be in, oh, I have written in the reverse format, I guess. Just follow the example, okay? If you're confused, I'm not going to rewriting it and then writing it. I'll just do it from the example directly. Now, in order to construct this NFA, right, we have to know what will be the Q for this one. So Q will be nothing but non-terminal N, and then in that, add extra one new non-terminal, which will be representing final state. So referring this example, you please modify the upper part because here I've made the mistake. Okay, here this one I've made a mistake in this. Others know it. Others know it. This one, right? I have made a mistake. This has to be exchanged. So whatever I've written, right, just follow the example strictly. So terminal with that extra non-terminal going to represent the final state. So let me represent that extra one as F1, or else because non-terminal I have already mentioned it has to be always capital letter. So instead of this one, right, let me write this one as F1. Okay, and then next summation will be nothing but terminal. This one from the given regular grammar, T will be equivalent to this one, and then next Q naught. What will be the Q naught? Q naught will be nothing but the start symbol. And then F, I'm not going to write anything for the moment. I'll just leave F as it is because we don't know which particular non-terminal will be considered as F depending on certain rules which I have already mentioned. Okay. So for the time being, I won't be writing any F, but already I have considered F1 as a new non-terminal. So I can write this one, or else I can say temporarily, because once we complete the complete machine, right, you have to modify this one. That's why I'm writing F is equal to F1 within the set temporarily, because in this, right, I have already introduced one new non-terminal which will be representing as a final state. That's why F1 as here. Now from this production, right, we are going to construct this transition function depending on three rules which we have already mentioned. Now let me construct transition function. Transition functions will be converted accordingly, whatever I have mentioned in this numbered format in this production things which I have just listed out here, 1 to 5. Now, this is as replaceable by 0. Now, this one is 3, rule number 3. Let me just write rule number 3. As per rule number 3, if the the production is of this format, then you have to add this transition. So let me add number 1, right? Delta S comma 0 will be F1. This is using rule number 3. Now number 2. Production number 2, T is replaceable by epsilon. Now see here, as per the rule number 1, if any of the for any of the non-terminal which you have in your regular grammar, if the production exists of this format, then you have to treat this N as a final state. Now, as per production rule number 2, T is replaceable by epsilon. So, let me write it here. As per rule number 1, T will be considered as final state. I have already told this is temporary one. Okay, one new final state is being introduced here. So this has to be updated. Okay, that's why I told it was temporarily. Now let me just. Now next, production number 3. Production number 3. Production number 3. See, as per rule number 2, if it is of this format, act like this. So I'll be doing that. Production number 3 is S replaceable by 1 followed by T. So S T. This is as per rule number 2. Okay. And then number 4 similar to this one. Number 4 delta, what was it? T0T. So T comma 0 replaceable by T as per rule number 2. Number 5 T replaceable by 1 T. T replaceable by 1 T, T1 T. as per rule number 2. Okay. Now see here. Let me let's update f from 1. Okay. Let me call this as equation number 1 or something. F1 comma t. As per rule number, as per rule 1, t has to be treated as final state. Now, I'm going to draw the diagram. I'm going to draw the diagram. Now, how many states are there? How many non-terminals are there? Let me just write here. S comma t comma f1, and then this is also needs to be updated. Okay, let me just write 2. Let me just write 2. I'm not going to update in here because this one no need. This one no need. STF1. This one no need. Now I'm going to draw the diagram. How many states? S T F1. Okay, and then S is the initial state. S is the initial state. Now, what about the transition? What about the transition? S comma 0 F1. S with input 0 F1. F1 is nothing but final state, remember? So this one, this is 0. And then S comma 1 T. S comma 1 T. Again, remember T is the final state. We have to treat T as final state. The next one is T with input 0 T. T with input 1 T. So this will be 0 comma 1. So this is the required NFA for the given regular grammar. Okay, this is the end of it. Tomorrow I'll be discussing one theorem. I'll end the class here, and then please sign out, and then I'll be sending you few enrollment number. Those enrollment number has to join it. You're going to have your test. Okay, so thank you.